All right, second part of this lesson is where we're going to go kind of backwards here. They're going to give us the zeros, and we have to come up with the equation. But knowing the factor theorem, that's going to really help us with this task. So on problem number 3, in your notes, y'all, like, draw a dotted line so you can, like, separate the two questions. Like, this was graphing. This is totally something different. We didn't do a good job on those notes there. So this is going in reverse. So what is the quadratic polynomial with the zeros at 3 and negative 3? Well, if you have x equals 3 and x equals negative 3, what factor did the solution 3 come from? X minus 3. What did the solution negative 3 come from? X plus 3. What do you do with these two factors? Multiply them together. Here we go. X times x gives me x squared. X times 3 gives me positive 3x. Negative 3 times x gives me negative 3x. Negative 3 times 3 gives me negative 9. Can I combine like terms? Yes. That came from x squared minus 9. See how we're just working in the opposite direction? Yeah. Okay. All right. Let's try another one. Let's make it a little bit harder. What is the cubic polynomial function in standard form with zeros at negative 2, positive 2, and 3? Can you all feel comfortable going straight into factored form?
Yes.
I asked, can you all feel comfortable? Do you all feel comfortable?
Yes.
Okay, good. So if I have negative 2 as a solution, what factor did that come from? X plus 2. What did 2 come from? X minus 2. What did 3 come from? X minus 3. So, what we're going to do is we're going to multiply the first 2 together, and then we're going to multiply that by the last factors. Okay? So, does it matter which 2 you start with? It really doesn't. Okay? They're all getting multiplied at some point, right? So if you wanted to multiply these 2 together first, you totally could. If you wanted to multiply the first 2 together, you totally could. Okay? It really doesn't matter how you multiply them together, as long as in the end they get multiplied. But I'm going to do the first 2 together because I recognize x plus 2 times x minus 2. That's going to be really nice when I multiply that out. X squared plus 2x minus 2x and then minus 4. That gives me x squared minus 4 times x minus 3. Do y'all remember the difference of 2 squares from last module? Like if it factored to x plus 2 and x minus 2, that came from x squared minus 4? Ah, okay, there we go. There's the connection. Okay, so if that ever happens, you know that that's the difference of 2 squares. So from here, we have to keep multiplying, right? X squared times x. X cubed. X squared times negative 3 gives me negative 3x squared. Negative 4 times x gives me negative 4x. And then negative 4 times negative 3 gives me positive 12. Now again, the fundamental theorem of algebra here can help you check your answer. How many solutions did you have? 3? What's your highest power here when you multiplied everything out?
3.
So you know you did something right. Okay. All right. Let's look at the next one. Ooh, this one's kind of a tricky one. We got negative 1, 1, and 0. What did negative 1 come from? That came from x plus 1. What about the 1? X minus 1. What did 0 come from?
X around the 2.
The x.
Like when there's like a round. There's 2 rounds.
An x on the outside.
Yes.
Yes. Good job, guys. Okay. Could you write x plus 0 as a factor? I mean, you could. But what's anything plus 0? Itself. Whoa. Not anything times 0, anything plus 0 is just itself, right? So 0 is just represented by x. Cool. Okay, here we go. What do y'all want to multiply first? The binomials? Yeah. I can use that vocabulary term now, right? You know what I'm talking about?
Yeah.
Sure. Last section, right? Binomial means two terms.
Oh.
Oh, yeah. So let's multiply the two binomials together. That simplifies to x squared minus 1, correct?
Yeah.
Lots of difference of squares today. And then I still have the x on the outside, correct? What do I need to do with that x? Yeah, we just distribute it out, right? So my final polynomial should be x cubed minus x. How are we doing? Good? No questions so far? Good. It's about to get a little bit harder. Oh, I know. Your favorite. All right. I'm going to help you with the one on the left. And then I'm going to leave y'all to do the one on the right. So what is the polynomial function in standard form with the following zeros? You know what to do first. Write it out in factored form. That came from x plus 1 times x minus 5 times x plus 2, correct? All right. Which 2 do you want to multiply first? First 2. Love it. Let's multiply these first 2 together. I would have x squared minus 5x plus x minus 5. That gives me x squared minus 4x minus 5, correct?
Yeah.
What do I do with that? Multiply it by the x plus 2. Now, this is why I'm saying it gets a little tricky, because you have to be super organized when you're multiplying a trinomial by a binomial. Be extra careful. What I do is I always take the first term and I distribute it out. Okay? X squared times x gives me what? X cubed. X squared times 2. Give me 2x squared. And I'm going to repeat the process with the next two terms. Negative 4x times x. Negative 4x squared. Negative 4x times 2. Negative 8x. And then lastly, negative 5 times x gives me negative 5x. Negative 5 times 2 gives me negative 10. It's a lot of multiplying, but is it tough? No. What's my last step here? Yeah, let's combine some like terms. This polynomial is x cubed minus 2x squared minus 13x minus 10. Nothing new here, right? Okay, just a lot of kind of simple multiplication. All right, see if y'all can do the next one on your own. I encourage you to hit pause and try this. I will work this out quietly for my friends to work this out on their own in class. When you are finished, please check the board. Make sure you got it. How do we do? Yes. Oh, love it. Yes. Awesome. Question? All right. should have gotten x to the 4th minus 3x cubed minus 10x squared plus 24x. I always, just kind of a helpful tip here, I always do my x last. So I can just like add the power, right? You see what I'm talking about? I'm like, oh, here's my equation. Oh, and then just give everything another x. I always wait till the very end. But that's just me. Do y'all have any other questions? No? All right. Let's talk about imaginary solutions. And then this is probably one of the hardest parts of today. And then we'll finish up with multiplicity, which is very easy. So what you need to know here about imaginary solutions, because we haven't dealt with them until right now. Complex factors come in pairs. This is extremely important, especially when we're talking about the fundamental theorem of algebra. Okay? So, for example, if you have 3i as a solution, you also have to have negative 3i. Why would I have the positive and the negative? Where do you think that came from? Yes. That plus or minus. When you take the square root, right? If you took the square root of negative 9, that would be plus or minus 3i, right? Those are two solutions sitting there. So we have to account for both. How do we do that? Let's look at this problem right here. It says, what's the polynomial in standard form with the factors negative 1 and 2i? Well, that negative 1 is a real solution, right? So if we have x equals negative 1, we know in factored form that came from x plus 1, and I'm done with that. Okay? When we have that 2i, when we have x equals 2i, okay, you technically have positive and negative 2i. Now, how can we turn that I back into a real number? We can square it, right? Because what do we know about I squared? It's negative 1. Good job, guys. So, x squared, what did the 2i come from? What did the solutions come from? And I think that's what you were talking about earlier, yeah? Okay. That came from negative 4, right? If you took the square root of negative 4, that would be positive negative 2i. So you can see that relationship, or you can think what I just showed you. Oh, if you have an I, square both sides. I squared is negative 1, 2 squared is 4. That's how we got here. Are y'all with me? You need me to say that one more time? In order to get rid of the I, square both sides. Because I squared is negative 1. Do you understand that you have to square the 2 as well? Okay, perfect. What do I need to do with that 4 to get it in this form? Just add it over. So that factor would be x squared plus 4. Now what do I do with these two? I multiply them together, and that's going to give me my original polynomial. So x plus 1 times x squared plus 4. Here we go. I have x cubed plus 4x plus x squared plus 4. Is that my final answer?
No, you put it in.
Yes, thank you. Put your final answer in standard form. So like I mentioned earlier, it doesn't matter how you multiply, right? But oh my gosh, it matters how you write your final answer. Put it in standard form. So this is why I say the plus and minus, right? Because you end up getting x cubed, correct? Right? Okay, but what do you see right here? You're like, money, there's only 2 solutions. There's technically 3 because that's a plus or minus. Okay. All right. Let's look at this bottom one here. On your notes, it did not copy correctly, okay? So be sure to change it. I want you to have the factors. What's the polynomial in standard form with the zeros at 5 and 2 minus 3i? That's what I want you to do. Five and 2 minus 3i, down here at the bottom. So we know about the 5. What did that come from? X minus 5. But if you have x is equal to 2 minus 3i, okay? If you have 2 minus 3i, on the top one you told me to just square both sides, right? But that was just an imaginary number. not a complex number. With a complex number, you need to move the real part over first. So we would say x minus 2 is equal to plus or minus 3i. Now, what can I do? Square both sides. So I get, oh, we need to talk about this. If I say x minus 2 quantity squared, so many of you all are wanting to say that's x squared plus 4. Heck no, that's not right. What do you need to do? Make 2 of them and multiply it out, okay? Because what actually is x minus 2 quantity squared?
X squared minus 4x plus 4.
Yeah. X squared minus 4x plus 4. So let's write that down. X squared minus 4x plus 4. I don't even need that first parenthesis. Is equal to, what's 3i squared? Mm-mm.
Plus or minus 9.
No. What happens when you square a positive? What happens when you square a positive? It's positive. What happens when you square a negative? It's also positive. So does that plus or minus really matter right now? No. What's 3i squared? Negative what? Negative 9. Now, what do we need to do with that 9? Add it over. So you have x squared minus 4x plus, what, 13? Is equal to 0. There. Now we're going to take that quadratic and multiply it by x minus 5. Okay. For the sake of time, you know how to multiply, correct? Yes? Okay. The important thing here that I need you to know, because I'm kind of running out of time here, I need you to know how to handle the complex solution. Okay? So, let's recap. We moved the real number over, and then we squared both sides. Are you with me? You sure? All right. Are we okay? All right. We're going to break this up into 3 parts. So the last part, we're going to talk about multiplicity.